Hello guys, we will come to the second class in our foundation course, Science and Technology Foundation course. In the first class, we have seen how we have to prepare for the science and technology. Okay, how we have to prepare for the science and technology subject with respect to UPSC. Okay, from this class onwards, we are going to see in this class particularly we will see the basic concepts that you have to know, okay, before you go and understand the advanced concepts like quantum computing, qubits, etc. When you try and understand about the electromagnetism and its applications, when you study about the compounds, etc., the details that we are going to study in this lecture are going to be very important. Means they are like basics. What is the meaning of nuclear fission? What is the meaning of nuclear fusion? What are atoms? What is an electron? What is a proton? Okay, what are isotopes, etc. These are the things that we are going to study in this lecture or in this video. Okay, so this is what I have dedicated for class 2, and class 3, 4, 5 also we will deal with the basic concepts. You see, the way I have designed these classes are, you can say they are not traditional. Okay, where you will take a topic and you will discuss everything. Unlike that, I have slightly taken a different path. So that's why I'm discussing all the basics that you might have studied until 10th standard. Okay, once we will revise them, we'll know once again about them. Then when you study advanced concepts, then they will become easier. At the time, you need not come back and see what is the meaning of an atom, what is an isotope, etc. You need not worry about these basic concepts at that time. Okay, so that is the purpose of these few classes that we are going to have before we enter into advanced topics. Okay, so in this topic we are going to discuss fundamentals of science and scientific concepts. I have taken some areas and the basic concepts in those areas we are going to study. Okay, and these are foundations that we require to understand modern technologies that we study at the advanced level. Okay, right. So first is we will see something like the concepts like waves and the radiation, where you will hear about them. Generally you might have already heard electromagnetic waves, okay, EM waves, where they are applicable in telecommunications, satellites, and in radar technology. You will generally hear about electromagnetic waves. Then another example I gave, that is radiation. So where you will hear about radiation or the word radiation in nuclear technology, medical imaging, and radiotherapy. At these places you will hear word radiation or concept called as radiation. If you take the area of matter and electricity, you will hear about atoms and molecules, where they are applicable in material technology, materials, and in nanotechnology. These concepts will come. Then when you study the concept, another concept is there, that is semiconductors. So where they are applicable, where you will have to know about semiconductors before you understand things like modern computing, chips, and electronics. There basically first you have to know what is a semiconductor, what is a diode, what is a transistor, etc., etc. Then another concepts, if you take the area of biology and the life sciences, their DNA and the cells, these basic concepts are there. About DNA and the cells, you have to know to further understand biotechnology, therapeutics, and gene editing, concepts like gene editing. Then if you go to the area of energy systems, there is a basic concept called as conversion. So where the principle or concept of conversion you have to know in order to understand things like batteries. Nowadays, lithium ion batteries have become much more popular, and we are searching beyond lithium ion batteries to store the energy. So, to understand the batteries, to understand the fuel cells, solar power, and the nuclear energy, you have to know something called as conversion. Okay, Right. So to understand broader aspects or emerging technologies, first you should have the knowledge of these basic concepts. So to understand those concepts, these following lectures will help us. Okay. Right. So we have already seen this, what is scientific knowledge, but once again we will remind ourselves. In the first class, we have studied what is the science and what is scientific knowledge and what is technological applications. Okay, so science is a systematic attempt to understand the natural world through several things like observation, rational inquiry, and reproducible evidence. Okay, for administrators or aspiring administrators like us, it builds the scientific temper essential to guide complex public policy. Okay, you see, in directive principles of state, I'm sorry, not in directive principles of state policy, but in fundamental duties also, you have one fundamental duty, that is to develop scientific temper. Okay, so scientific knowledge will help become a what should I say, a scientifically sound person and the person who has scientific temper. Okay, so so if you see what is a scientific method, it is a systematic attempt to understand the world through rigorous, reproducible steps like observation and measurement, experimentation and evidence, logical reasoning, hypothesis testing. Okay, so all these steps are involved in this scientific method. Then what is scientific temper? It is an essential mental framework and attitude characterized by questioning and rational inquiry, evidence based reasoning, etc. etc. So, this is what is called as scientific temper. Other aspects, if you see, willingness to revise views, rejection of unsupported claims, etc. etc. This is what is called as scientific temper. Okay, so for example, simple example, let me tell you, you should not see when there is, people say you have to you should not see solar eclipse or lunar eclipse. So just you blindly believe that, or you will ask further questions, why we should not look at the solar eclipse, what happens if I look at it, etc. You have to question it and you have to go on questioning uh, until you get the right answer for that. Okay, so this is what is called as scientific temper, and having scientific temper is very much relevant in countries like ours, India, where superstitions are far larger. Means many people still believe in superstitions, and some people are duped by some other people because people blindly believe in superstitions. So as an aspiring administrator, you should have scientific temper and you should make other people to develop and cultivate scientific temper so as to protect themselves from the people who are duping them, by using these blind beliefs. Okay, then, if you see the policy implications, administrators face a complex socio-technical challenges in situations like public health, vaccines, and artificial intelligence. You know, some people reject vaccines. Why? There is some belief that they harm people, they harm them. But being a scientifically tempered person, you should convince those people to take vaccines. Okay, then in climate and environmental technology, biotechnology and nuclear energy also, you have to deal with many administrative and policy related aspects, and in that scientific knowledge helps you a lot. Okay, right. So, right, we will come to the actual subject, and we will understand basic concepts one after the other. So, first we will see what is matter. You see, matter is the foundation of the physical world. How our universe is built? It is built with matter. So, matter is there in universe. Okay, even our Earth, other planets, other stars. Okay, all these things are made up of matter. Okay, you see, it is one of the most basic concepts in science. Okay, so matter is one of the most basic concepts in science. You see, anything that has mass and occupies a space is called as mass. So what is mass? Mass is anything that has what is matter? I'm sorry, what is matter? Matter is anything that has a mass, means it has some weight and it occupies some space, that is called as matter. Okay, right. So matter is defined strictly by two parameters: possessing mass and occupying physical space. If you have to see the matter, examples for matter: atmospheric air and water, this is air and water, this is matter. Then lithosphere, okay, that is lithosphere of our earth, which contains soil, rocks, metals, it is also matter. Then human bodies and biological matter, like plants, plant leaves, flowers, fruits, human body, other animals bodies, that is also matter. Then planetary and astronomical bodies, like other stars, then other planets, okay, comets are there, many other things are there in the universe, all that are also matter. Okay, so matter, how many states you will find matter? Classical science says that matter can be found in three states, that is solid state, liquid state and gaseous state. But the modern science says that one more state of matter is also there, that is plasma. Okay, that is semi liquid and semi solid form. Okay, you can call it as plasma. Okay, state of matter is also added in recent days. Okay, so that is what I'm going to say, modern advanced states. I think you know what is solid, what is liquid and what is gaseous. I did not go into further details. Okay, so what is plasma? Plasma is, it is a superheated gas composed of highly energetic ions and free electrons. So the free electrons are very very important in science. We are going to study about them. Okay, because some elements or materials have free electrons, they start behaving in a different manner, that we are going to see in the future. Okay, so this plasma is crucial for understanding nuclear fusion and stellar physics. Okay, interstellar, to understand that, okay, universe, plasma, the state of plasma becomes very very important. Okay, then Bose Einstein condensate is also there. I think we will study, when we study Indian scientists, we will study about these Bose Einstein condensate also. What it is a state of matter of a dilute gas of bosons. You see, bosons are some kind of particles like electrons, protons, neutrons. Bosons are also there. Okay, they cooled to temperatures very close to absolute zero, exposing quantum effects. So because of that, quantum physics starts emerging. Okay. Then there are some specialized states also. Under extreme astrophysical or high energy conditions, you will see some specialized states of matter also. But basically, how many states you can say? Four states you can say: solid, liquid and gas and plasma state of matter. Then now we will understand what are atoms, molecules and elements. Right. What is an atom? An atom is the basic unit of an element that retains the chemical identity of that element. Okay. It consists primarily three subatomic particles. Those are, I think you know them very well. Those are protons, neutrons and electrons. You might have studied in your school. Okay, so first of all, this is, you can say, this is the atom. Okay, which has nucleus. Okay, and this is rest of the body of the atom. You know very well, in nucleus all the mass of the atom is actually concentrated in the nucleus, and here you will see protons and neutrons in the nucleus. Then in the rest of the body of the atom, you will see electrons roaming in different orbits. Okay, electrons will be roaming in different orbits. That is how the structure of the atom is. Okay, so I have told atom has two components. One is nucleus, and the second thing is rest of the body. Okay, so in nucleus comprises of protons and neutrons. You see, Protons are positively charged particles. That's why plus plus symbol you will see here. Plus plus symbol you will see here. Then they are located directly within the dense central nucleus. Okay, those are protons. Then neutrons, they are electronically neutral. They do not have any charge. They are neutral. That's why they are called as neutrons. But remember, they have mass. Okay, they share the nucleus with the protons. So in nucleus, you will find both protons and neutrons. Okay, then we will see electron cloud which surrounds the nucleus. Okay, you see they are negatively charged particles. Okay, and they do not have mass. Okay, so they are associated with the region surrounding the nucleus. Okay, right. So these electrons are extremely light particles. You can say they have almost zero mass. They are, and they orbit the nucleus, means they will be roaming around the nucleus. Okay, orbiting around the nucleus, just like the earth and other planets. Okay, circle the sun, just like that electrons circle the nucleus. Okay, and they, remember, they orbit the nucleus in a defined energy levels or clouds. Okay, right. So if you see the structural structure of an atom, every atom structurally organized into two main physical domains. So what are those? First one is central nucleus, I have told you. This holds the heavy protons and neutrons which have mass, containing almost all the atoms mass. Then outer electron cloud is there. This determines the chemical bonding properties, reactivity, and electrical interactions. Okay, so this is the structure of the atom. Remember it, very very important. Then we will come to another important basic concept, that is atomic number and mass number. I think, I don't know, you have written, you might have written in lower classes like this, H11, then helium, like that. I don't know you remember it or not. So this is what is atomic number, you write below at the foot, and this is atomic mass. Okay, this is mass number, which you write on the head of the element. Okay, symbols, elements a symbol. Okay, right. You see, an element's identity and physical mass are, they are governed by the precise quantities of its subatomic constituents. Okay, first we will see atomic number Z. It is also represented with Z, letter Z, or alphabet Z. You see the fundamental property. This is the fundamental property. Atomic number is the fundamental property that defines each individual element. Okay, elements are there in the periodic table. You know what is periodic table. Okay, elements are there. So atomic number defines the fundamental property of the element. It defines what actually atomic number shows. It shows the total number of protons that are present in the nucleus of the atom. Okay, that is atomic number. So it is nothing but the number of protons that are there in the nucleus of an atom. Okay, it acts as the chemical signature of the atom. It uniquely determines the identity of the element. Okay, atomic number uniquely determines the identity of the element. So hydrogen, if you see, for example, how many protons it has? One. That's why I have written 1 1. Carbon, if you see, its atomic number is 6, C6 we will write. Then oxygen atomic number is 8, that's why we will write O8. Okay, right. Then we will come to mass number. So it is represented with the alphabet A. What is mass number? It is total structural mass concentrated within the dense core of the atom, that is nucleus of the atom. Okay, it represents, mass number represents the combined sum of protons and neutrons. So indirectly you are saying how many number of protons and neutrons are there in the nucleus of the atom. Remember, most of the times the protons and neutrons will be equal. Most of the times I am saying, but sometimes there is some difference. There will be slight difference, 1 2 difference will be there in the number of protons and the neutrons. Okay. And this number, mass number, is very important in identifying the isotopes. We will study about isotopes. Okay. The isotopes are atoms of the same element with the varying neutron counts. Means in isotopes the atomic number will be same, but they are the same element, but their neutrons differ in each of them. They are called as isotopes. We will see in the next slide. So mass number is what? It is the atomic number plus number of neutrons the nucleus or atom has. Okay. In other way, you can also say it is the protons, number of protons plus number of neutrons. That is also you can define mass number. Okay. Right. Then we will come to isotopes. Very, very important. Many times you will be hearing isotopes. Okay. Carbon isotopes, hydrogen isotopes. Okay. Some radioactive materials are there. Okay. Like uranium isotopes you will hear. Okay. Plutonium is there. Its isotopes you will hear. Sodium isotopes. They are all used in either in food processing or in medical field. So to understand those isotopes, you have to understand here the concept of isotopes. Okay. Right. You see, uh, if you see the core scientific concept of isotopes, isotopes represent atoms of the same element. They are of same element that share an identical number of protons but differ structurally in their neutron count. Means number of neutrons differ in them. Okay. So you see they maintain the same atomic number Z, meaning their electron arrangement and chemical behaviors remain identical, but physically they exhibit different behavior. You see they possess a different mass numbers, modifying their physical properties and nuclear characteristics. So because of that reason, because of difference in number of neutrons, they start exhibiting different physical behavior. You see in chemical behavior no change is there, but in physical behavior there is a change. Okay. So examples are protonium. One example is there. In protonium, one proton is there but zero neutrons are there. Okay. You can say it's H11. Then there is deuterium. Okay. In it one proton is there, neutron is there. So you will write it as H12. Then tritium is there. Okay, this is H13. Okay, I'm sorry, H13. Okay, these are the three isotopes of hydrogen. Okay, so these three are same element, that is hydrogen, but here zero neutrons are there. Here one neutron is there. Here two neutrons are there. So one proton plus two neutrons, mass number becomes 3. Okay. Right. So one thing you have to remember is the concept of mass imbalance and stability will become particularly important in nuclear science that we are going to study in the coming future. Okay. So the fundamental principle here is same protons plus different neutrons. Because of that, there is the result is difference in mass, and that's why we are able to see isotopes. You see, this is a good phenomenon. It is not a bad phenomenon. Because of these difference in mass, several applications are there. Okay, so the applications of isotopes we are going to see in several areas, like medicine. Okay, in diagnosis, then in treating the cancer, we are using isotopes. Then in agriculture and industry also, especially in food preservation, and in testing some cracks we are using the isotopes. Okay, then in research and energy areas also we are utilizing the isotopes. Okay. Right. Next area we will try and understand is molecules and compounds. What are molecules and what are compounds? Okay. So if you see the concept of molecules and bonds, you see atoms. We have seen individual atoms, hydrogen, oxygen, carbon, etc. They combine chemically, bonds will be formed in between them. I'm sorry, it's not bond, it's bond, B-O-N-D, bond. Okay, so atoms are not stable, you know very well, because some free electrons will be there in most of the atoms. If you leave out these, elements like krypton, xenon, neon, these are stable elements. Otherwise most of the elements are unstable because they have free electrons. Okay, right, because of that, to get the required number of electrons in orbits, atoms come together and they will form compounds. Okay, so atoms combine chemically to form molecules representing the smallest fundamental unit of a chemical compound. Okay, for example, the basic example we will take H2O, water. Okay, so H2O represents water consisting of hydrogen and oxygen atoms chemically bonded together. So hydrogen is a different element, oxygen is a different element. So because of the bond between hydrogen and oxygen, we are seeing the molecule of water. Okay, right. So what is a compound? A compound is a substance formed when two or more different elements combine chemically in fixed proportions. You see, it is not a random proportion, it is fixed proportion. Examples for compounds are water, H2O, carbon dioxide, CO2, sodium, sodium chloride, NaCl, daily salt, table salt, we will see. Okay, these are the common examples for compounds. Complex compounds are also there. You will see in when you go to organic chemistry. I don't know if you have remembered organic chemistry, if you have studied chemistry, you have taken chemistry in your plus one and plus two. Complex compounds will be formed by carbon. Okay, these examples what we have seen are simple compounds. Okay, right. So where these concept of molecules and compounds will be useful in biotechnology and pharma, in materials and nanotechnology, in batteries and energy fuels, in environmental chemistry. In these areas, understanding molecules and compounds becomes very very important. Okay, right. Next we will see why the electrons matter. Okay, electrons, I told, because of the charge, electrons are negatively charged. Why they matter, we will try and understand. Okay, you see, the electron is particularly crucial in modern science. Why? You see, electricity, simply we say electricity has become very very important in our country, in our life, I'm sorry, in our life. Okay, we, without electricity we cannot imagine our life now. So what is electricity? It is nothing but flow of electrons. Okay, what is electricity? Supply of electricity, it is nothing but flow of electrons. Okay, so electrons have very 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 important significance in our life. Okay, you see, the behavior of electrons determines the fundamental chemical, electrical, and optical properties of all physical materials. So they define the proper or fundamental behavior of the materials. What are those behaviors? Chemical behavior, electrical behavior, and optical properties of matter will be decided by the electrons. Okay, you see, we can divide materials into some categories. Okay, when atoms combine, their electron configurations govern how the resulting material behaves, and based on the behavior we can classify materials into these categories. So what are conductors? They have free flowing electron pathways, means they allow electrons to move from one atom to another. So best examples are all the materials or metals which allow the passage of electricity, copper, iron, etc., etc. Many examples you can take. Then insulators are there. So what are these? They are tightly bound electrons blocking flow. So you will not see flow of electrons in insulators. For that reason, they are called as insulators. They do not allow the flow of electrons. Why? Free electrons are not there in them. Okay, all the electrons are chemically binded or bonded. What is happening in conductors? They have some free electrons, so that's why those free electrons will keep on moving. So that's why actually they are called as conductors. Okay, Then there are semiconductors, very, very, very important materials, I would say, on Earth, semiconductors. Okay, so they sometimes they allow the passage of the flow of the electrons, sometimes they do not allow. So that's why they are called as semi half conductors. Sometimes they allow flow of electron or movement of electron, sometimes they do not allow. Okay, so I know the most famous ones, semiconductors. I hope you know. If you are ready, you can comment in the comments box. Okay, the silicon and germanium, the most important semiconductors on Earth. Okay, so now our entire life, we can say, is hovering around these semiconductors, especially two materials, silicon and germanium. Without these two materials, we cannot simply imagine our life. Okay. Right. So, way these concepts of electrons or the materials, type of materials like conductors, insulators, semiconductors is useful. Electrons and electricity, to understand that we need them. Then electronics and the semiconductors. Then in transistors and integrated circuits. Then computers and digital technology. You see, in order to understand the latest computers, the present computers and digital technology, you have to have the knowledge of electrons. Okay, diodes, transistors, then chips. Okay, integrated chip. This is nothing but an IC, integrated chip. Okay, so to understand this, all this information you should know. Okay, so that's why electrons are very, very important. Okay, then we'll come to nucleus, the center of the atom. Okay, this is what is nucleus. So the atomic nucleus is an incredibly dense region at the center of the atom. We have already seen it. It is containing the key subatomic particles, okay, collectively known as nucleons. Okay, both protons and neutrons are called as nucleons because they are present in the nucleus. So protons, they have positive charge and mass. We have seen it. Uh, they exert, okay, because they like charges, okay, they exert a powerful electromagnetic repulsion against one another. Okay, the protons that are present in the nucleus, they against each other because they are, both of them are positively charged. Okay, their charge is the same. They exert a repulsive force against each other. So because of that reason, center or nucleus will be very, very unstable in certain atoms. We will see that. So here comes the utility of the neutrons, which have negative charge. You see, electronically, neutrons are electronically or electrically neutral nucleons that act as nuclear stabilizers within the core. So because protons are exerting a repulsive force against each other, in between the neutrons will stay and they will try to neutralize that force. Okay, in the core. That's why the core or nucleus of the atom will remain stable for certain period, and it depends on how many protons are there and how many neutrons are there in that particular atom. Okay, then if you have to see the concepts of binding and instability, how does a nucleus stay bound despite electrostatic repulsion? The secret lies in a balance of fundamental forces. So what is that balance? Strong interaction is the first one. So this is extremely powerful force that operates over very short distances, overcoming electromagnetic repulsion to hold the nucleons together. Okay, so there is a powerful force that is binding the protons together, and that's why they are, even though they are repulsing each other with a lot of electromagnetic force, still they are bound together. Then radioactivity, where the force is not sufficient to keep these protons together, some of the protons will escape the nucleus. Okay, some of the protons will escape the nucleus. So in that at that time, lot of energy will be released along with the protons, or along with the, sometimes the neutrons also will get released. Along with that, lot of energy will be released. Okay, that is what is called as a radioactivity. Okay, so not all proton neutron configurations are stable, some of them are unstable. So those are actually called as radioactive atoms or radioactive materials that you will see: uranium, plutonium, etc., thorium, etc. Okay, so all proton neutron configurations are stable. Some unstable combinations are there, and they undergo spontaneous transformation, and in that process lot of energy is being released. So that is what is nuclear energy. How we are producing nuclear energy? Because we are utilizing the property of radioactivity of some materials like uranium, plutonium, and we are producing nuclear energy. That is what we are going to study in the advanced classes. Okay, right. So further, if you have to understand it further, so the what is radioactivity? Right. So radioactivity is the spontaneous transformation of an unstable atomic nucleus, the center, accompanied by the emission of radiation, lot of amount of radiation. These differences are important. There are some differences in radiation or in radioactivity or the radiation that is being released in this process, and they are known as alpha radiation, beta radiation, and gamma radiation. Just you know the names of the different types of radiations. That's it. You need not go beyond that. Remember, there are three types of radiations. Those are alpha, beta, and gamma. Okay. All right. So in image, you can remember. Okay. What are alpha, beta, and gamma radiations? Okay. Then another concept we will see, that is ionizing radiation. Okay. So what is ionizing radiation? Okay, we have seen the radiation is classified into different matters based on whether it has sufficient energy to ionize atoms or molecules. Okay, so ionizing radiation can remove electrons from atoms or molecules, damaging biological tissues and DNA when exposure is very high, yet enabling critical clinical and industrial applications. So there are some applications for those. For example, you might have seen laser light. It is dangerous. Then X-rays are there. They are also, X-rays should not fall on our eyes. Okay, but X-ray is used to scan our bones. So applications are also there, but at the same time they can create harm also. So what is ionizing radiation? They can remove electrons either from atoms or from molecules. Okay, and this ionizing radiation has a lot of applications in our day-to-day life. Okay, you see, ionizing radiation possesses sufficient energy to strip tightly bound electrons from the orbits of atoms or of molecules, creating highly reactive ions. Okay, so key ionizing sources, if you see alpha and beta, these radiation, it is charged particulate emissions with the high ionizing power. Then X-rays and gamma rays are also there. They are high frequency electromagnetic waves. Then ultraviolet radiation is also there. It is high energy band of the UV spectrum, ultraviolet spectrum. Okay, so what is the biological impact of these ionizing radiations? You see, this ionization can disrupt molecular bonds, damaging the DNA and biological tissues if poorly controlled. They are dangerous in an uncontrolled manner. Okay, but they also have some applications where in cancer treatment, you see, targeted cancer cells can be removed through radiotherapy. They can destroy the malignant, means malfunctioning tumor tissues. They can be used in diagnosis also. You see diagnostic images such as X-rays and a CT scan, they are used there. And in sterilization also they are used, eliminating, they will be used in eliminating pathogens in medical tools and even in food also. So radiation has these many applications. Okay, there is another concept called as half-life, very important. You see, half-life, every material decays. Okay, you see, half-life represents a geometric progression where elements, okay, where a molecule is there or atom is there, its a parent nuclei center decreases by 50% with each interval. Okay, right. You see, for example, I am taking an element, oxygen I am taking. Okay. For example, I am saying the half-life of oxygen is 25 years. So what is the meaning of it? In 25 years, 100 units of oxygen is there in the nucleus of the oxygen. So after 25 years, it will become 50%. Okay. After another 25 years, it will become 25 units. After another 25 years, it will become 12.5. Okay. After another 25 years, its units in its mass will become, nucleus will become 6.25 units. This is what is called as half-life of an atom or an element. Very, very, very important concept. Okay. So what is half-life? Half-life represents the geometric progression where a element's parent nuclei decreases by 50 with each interval. Okay. For example, 100 units of an atom or an element is there. Okay. So initially it has 100 units. For example, first half life, for example, this element's half life is 100, or we will take 1000 years. So you see, for carbon, there is a method called as carbon dating system, which is used in history. Okay. Very, very important that how it works. Carbon dating method, it works based on the principle of half life only. Okay. So in the first half life, 50 units of that element will remain. In the next half life, means up to 500 years, 50 units of that element will remain. Then in 200 another 50 years, sorry, in another 1000 years, 25 units of that element will remain. In the next 1000 years, 12.5 units of that element will remain. Okay. So this predictable decline occurs regardless of the initial quantity or environmental factors. Okay, that is the important thing. So where they are useful, these half-life, principle of half-life. Okay. You see, because different isotopes decay at a widely different rates. Isotopes, they belong to same element, but because their atomic mass number is different, they have different decay periods. So by studying the half-life of or decay of isotopes, from milliseconds, sometimes they have half-life of milliseconds, and sometimes they have billions of years. Okay. So it has critical applications. It is used in nuclear medicines. You see, dosage will be decided based on the half-life of isotopes. Then in radioactive dating, like I told, in studying the earlier civilizations. Okay. Radioactive dating is used. Okay. In that, very, very important one is carbon dating method. Okay. So this determines the age of organic matter and geological structures. Okay. Then in radiation safety also it is used, is by defining exclusion zones and protective protocols. It is used in radiation safety also. Then in waste management also it is used by planting long-term storage configurations for used fuel. Okay, the fuel that we use in nuclear reactors, we will bury it underground. Now we are burying it in underground. So because of the principle that it has a decaying principle, so we can have an idea by what time, after how many years, the radioactive material that we have buried underground will exhaust completely. Okay. So in this image, it is beautifully shown the prospect of the principle of half-life. Okay. How much it is remaining after every period of or episode of half-life. All right. Then another important concept that we will see, that is nuclear fission. Okay, nuclear fission, which is nothing but, center is there, nucleus is there in an atom, it will break away. Okay, that is what is called as nuclear fission. So what is nuclear fission? When a heavy atomic nucleus, means if you go to the in the periodic table, if you go to elements or atoms which have higher atomic number, I have taken the examples of plutonium, uranium, thorium, radioactive materials with high atomic number. Okay, so the heavy atomic nucleus, it absorbs a neutron and it becomes highly unstable and splits into two or more smaller nuclei. Okay, so heavy atomic nucleus is there, it will take absorb a neutron, and because of the absorption of neutron, the force that is binding these elements or particles that are there in the nucleus, the force will not be sufficient. That's why the nucleus will split and two or more smaller nuclei will be formed, and a different atom will, or two or more different atoms will be born. So when we study these nuclear energy, we will study it in much more detail. Okay, this is the concept of nuclear fission. So what is the result? The result is here lot of energy is being released. Okay, and some neutrons, free neutrons will also emerge in this process. That is what is called as nuclear fission. So in the image, that is what we try to depict. This is the heavier nuclei, and one neutron is entering here, and because of that, it's breaking, nucleus is breaking and forming into different nucleus, two different nuclei, and in the process you can also see some neutrons are emerging. Okay, free neutrons are emerging in the process also. Okay, so what is the result of fission? Kinetic energy, lot of kinetic energy of fragments is converted into thermal energy, means lot of heat is generated in this process. Then additional neutrons are being released. Okay, then you can divide this reaction into chain reaction, means you can control this nuclear fission and you can make it as a continuous chain reaction. Okay, or you can make it as uncontrolled reaction also. So where this chain, uncontrolled chain reaction is used, it is used in nuclear weapons, nuclear bombs, atomic bombs. Atom bomb works on uncontrolled nuclear fission, whereas when the fission is controlled, it is used in nuclear reactor. Okay, it is used in nuclear reactors. Okay, so uncontrolled reaction, it is exponential, rapidly cascade, and it result in explosive release of energy. That is what is being used in atom bombs. Okay, then controlled reaction, it is regulated using of materials, okay, that absorb the excess neutrons and maintain the stable output. So nuclear reactor works based on this principle only. So whatever the free neutrons that are emerging, they will be absorbed, and one more neutron will be kept free and it will go and hit the another nuclei or nucleus. Then same thing, energy will be released and some free neutrons will be emerging. The desired amount of additional neutrons will be once again absorbed and the desired number of neutrons will be kept free. In that way, it will become a controlled chain, controlled reaction. That is the principle that is being used in the nuclear reactors. Okay, then nuclear power, that is what I am saying. Fission technology is being used to produce electricity. Okay, don't worry, when we study nuclear energy, we will study in detail about these, how fission technology is used to produce electricity. Okay, that is what is that is how the nuclear reactors are functioning and the nuclear energy is being generated. Then nuclear fusion is also there. So what is happening in nuclear fusion? Two or more smaller particles and nuclei is coming together and they are fusing. Okay, coming together and becoming a single nucleus. Okay, so what is fusion? Fusion is fundamentally different, completely opposite to actually nuclear fission. In fission, breaking of single nucleus is there. In fusion, what is happening? Two separate or two or more separate nuclei coming together and becoming a single nucleus. That is what is nuclear fusion. In this process also, tons of lakhs of tons of more energy is, or heat is being released. Okay, so fusion is fundamentally different or opposite to fission. In fusion, light atomic nuclei, basically we do it with hydrogen. Okay, two hydrogen atoms will come together their nuclei will fuse, and one nucleus will be formed, that will be of helium. So two hydrogen particles will come together and a helium atom will be formed. Okay, that is what is fusion. Okay, so light atomic nuclei will combine to form a heavier nucleus, releasing immense energy under extreme conditions. So in sun star is there, sun the source of energy for us. What is happening in sun? This is what is happening: nuclear fusion is happening. Sun has lot of latent abundant amount of hydrogen particles, and they are coming together because sun is extremely heat. By utilizing that heat, hydrogen particles are coming together and they are fusing, and they are being formed into helium, which is a stable atom. Okay, right. So fusion is the fundamental process that powers the sun and rest of the stars. Okay, that's how they are releasing enormous amount of energy regularly on continuous basis. Then what is the reaction? Light nuclei, for example hydrogen isotopes, they come together uh, under the circumstances of extreme heat and pressure. Then because of the fusion, heavier helium atom is being formed. Okay, and in that lot of free energy is being released. So to actually mimic that fusion on Earth, until now we have not done it. We are experimenting. We are trying to do it. We are experimenting. Okay. First, we have to create extreme conditions to do that. So nuclear fusion requires replicating stellar core, means universal core, temperatures exceeding 50 million degrees Celsius. You imagine it. Then you see, it also needs powerful magnetic fields or high powered lasers to safely confine the reactive plasma. Okay, then we can commercially start exploiting it. But let me tell you, it's until now it was not possible. We are experimenting. Several countries are experimenting nuclear fusion. Okay, right. So why lot of energy is being released when this nuclear fission or nuclear fusion takes place? So it will be explained by the famous Einsteinian principle: E is equal to c square energy. Okay, so matter, c is the speed of the light and m is the mass. So because of slight difference in the change of the speed of the light, enormous difference will come in this equation. So E is nothing but energy, right? That's why lot of energy is being released. Okay, right. So that is how you can understand lot of energy is being released when nuclear fission or nuclear fusion takes place. Okay, right. So these are some of the basic concepts I tried to explain to you. Remember, once again, when the related topics will come, once again we will revise these topics. But to understand critical topics like nuclear energy, etc., biotechnology, etc., these basic concepts are required. So some prelims questions are there. We will see for your practice. Consider the following statements. First statement is atomic number is determined by the number of protons in an atom. So obviously statement is correct. Second statement is isotopes of an element have the same number of protons. Okay, this is also correct statement. Then third statement is isotopes necessarily have the same mass number. So this is incorrect statement. Which of the above statements given is or are correct? So I forgot to give the options, but okay, only statement 1 is correct, only statement 2 is correct, only statement 1 and 2 are correct, all the above statements are correct, like that. So what is the answer? Answer is 1 and statements 1 and 2 only correct. So for your practice, two more questions are there. You try to go through the questions. Okay, and then one mains question also, two mains questions also I try to give you. First question is explain how an understanding of atomic structure provides the foundation for modern technologies such as nuclear energy, electronics, and advanced material. Now, I think with the brief information you have, maybe it will become difficult for you to answer, but still you can try and answer. Okay, you can say this is the this is the starting period. So you try to write the answer maybe in 100 words. It's more than sufficient. Another question is also there. If you want to, you can try and answer that question also. Okay, so this is what you have to learn in this class. Basics I try to explain to you, but still nonetheless they are also important. You try to go through the concepts and try to understand them. Okay, you see supporting reading material is also there for this discussion, whatever the discussion we had. If you want the PPT, actually I'm unable to upload these documents, the supporting material, Word document. If you require these documents, both PPT and doc file, Word document, for the lot of reading material is there, you message me. Okay, you can comment in the comment section. I will try to share the link with you. Okay, right. So that's it for today. See you next time. Until then, you have a very good time. Right? See you next time.